is considered age of 20 years.
Alright, today we are going to start, and those congruent sides are called the legs. So if we're looking at this triangle right here, we would say that AB and CB are the legs. The angle formed by those legs is called the vertex angle. So this would be the vertex angle. And then the other two, these two, A and C, are base angles. Well, that's too bad. So, if two sides of a triangle are congruent, meaning the triangle is isosceles, then we automatically know that the two angles opposite those sides are also congruent. Okay? And it works the other way too. If we know that two angles in a triangle are congruent, we automatically know that the two sides opposite them are congruent. Okay? So in an isosceles triangle, we will have to have two congruent sides and two congruent angles. Okay? So, first, we're just going to work with a little bit of algebra here. Okay? So, in this first example, I'm told that BC and BA are congruent, and then I'm given information about the angles on the inside. Okay? Well, if I know that these two sides are congruent, that automatically means these two angles opposite them are congruent. So, to set up an equation here, I can set these two angles equal to each other. So we can say 5x minus 10 equals 4x plus 5. Pretty straightforward equation to solve then. Subtract the 4x over. X minus 10 equals 5. Add the 10 over. We get x equals 15. Exactly. So that's the next example, right? So we're given that angles S and T are congruent, but then we're given expressions for the sides opposite them. So if I know that these two angles are congruent, I can automatically conclude that the two sides then are congruent. So I can set these expressions equal. So 3x minus 13 equals 2x. If the x is on one side, right, yeah. For it to be an isosceles triangle, we would have to have two congruent sides. For now, yes. Yeah, so let's take a minute and try a couple of these here, okay? Under the exercises down here, okay, we are given, and these are all isosceles triangles, right? Some of them were given that the sides are congruent and we need to solve for angles. Some of them were given that the angles are congruent and we need to solve for sides. Okay, but all 6 of these examples down here are isosceles triangles. So let's take a couple of minutes here and practice some of these. Stuck already. Wait till you go up here. A lot better. You better go. Got it. Here's what's coming.
It is something very impressive. Mathematical piece. I don't think you actually did, but he does. He showed me pretty impressive. You can name all the numbers. You know what? Yeah, usually. No,
So as I was walking around, I saw a few mistakes on a couple of these. On a lot of these triangles, we're not given the two base angles. We're given a vertex angle and a base angle. So what we need to say is, well, the sides that are opposite the congruent, or I'm sorry, the angles that are opposite the congruent sides are the ones that would be congruent. So if PQ and PR are my congruent sides, then angles R and Q would be my congruent angles. So if this one's 2x, this one would be 2x, right? So I'm not setting 2x equal to 40, right? What we can do now, if I know that this one's 2x, I can say all three of these angles would have to add to 180. So 2x plus 40 equals 180, right? And then solve that equation. Okay, and it's for quite a few of these actually. It's a similar idea. So we just need to make sure that we're being careful in saying the angles that are opposite the congruent sides are the ones that are congruent. Okay, the 40 and the 2x in this case are not the same. Alright, so if you need to go back and fix a couple of those, I'll give you a minute to go back and fix that.
Well, when I did mine, I figured out what I solved though. I solved the R. That's what I did. I get R.
Okay, so you got that R was 70. So should be
X equals
40. Oh, but 40 is 35.
It says 30. Oh my goodness, that's awesome. so long. I just like know this stuff.
We just know this stuff.
Oh,
That's not how the world works.
we should make it that way. Yeah.
If we have both the base angles, the base sides are good, right?
Do we use the theory for that? So like, is that our reason, the theory?
Like these theorems?
Yeah.
Yeah. So once you were able to show that the angles are congruent, then then we're going to use those theorems on top. All right. Did we get these answers for 1 through 6?
I got 1 through 100.
Check your answers up here. Right.
Wow. Yeah. I think.
Are there any questions? Any that we want to talk about in any more detail? Well, let's see. So these two sides should be congruent. So we can say 2x plus 6 equals 3x minus 6. So we'll get the variables on one side. So I'll subtract the 2x over here. Add the 6 over.
I didn't subtract.
Any other questions on these 6? Triangle angle sum theorem would be the actual name for it. The idea that all the angles in a triangle add one angle. Yep. Triangle angle sum.
Oh, some.
Yes.
How do you say some?
No, like SU sum. All right, so let's take a look at this proof down here. Okay, so on this proof, I am given that angles 1 and 2 are congruent, and my goal is to prove that sides AB and CB are congruent. Okay? Well, using this idea of isosceles, if I'm able to prove that angles 1 and 3 are congruent, then I can claim that their opposite sides, which would be AB and CB, are congruent using that theorem up at the top. Okay?
Angle 2 and angle 3 is congruent because they're vertical.
Right. So let me write down the given here first. And that is true as well. So we're given angles 1 and 2. So these two are congruent. And then Katie just told us that angles 2 and 3 are congruent because they are vertical. Alright, so now we're not there yet. Okay, so we've got 1 and 2 congruent, and now 2 and 3 congruent. So now we have to say that angles 1 and 3 are congruent, and we can do that because they're both congruent to the same thing. Right? They're both congruent to angle 2. So now I can say they are congruent to each other by the transitive property. Technically, we could use substitution for that as well. Okay, so now once we've shown that angles 1 and 3 are congruent, now I can claim that their opposite sides are congruent. Okay, so now we can say what we want to say. Right? Now we can say AB and CB are congruent. So yeah, which one is it? If we've shown the angles are congruent,
It's CID.
the converse, the isosceles triangle theorem.
Or it could be
Which one?
cat.
Tell me.
Converse.
The converse or the regular one?
Converse.
Cat. King. Cat and Titanic. Yes. Cat and Titanic. You're ready for the next process we'll learn about things. Cats and Titanic.
Well, you're my only honors class.
We are.
Yes.
Yeah, when they come to this, when they come to this, tomorrow, when they come to this, I think you should tell them about cats in the Titanic.
All right. I'll remember that.
You tell them about alpacas.
Why do we have to use the transitive property if we already know that that angle is congruent?
If we already know which angle is congruent.
Okay, so when we do the vertical angles and it makes 3 congruent to 2, why do we have to do the transitive 2?
Well, in order to say that this is an isosceles triangle, we have to state that these two angles are congruent. I mean, like, we have that because we know 1 and 2 are congruent and 2 and 3 are congruent, but we actually have to state that 1 and 3 are congruent because of that. I mean, right, it's like common sense, but we actually do have to state that. Any other questions? The 22nd.
Oh my god, my
What? You better start celebrating now.
Why is that?
Alright, so on the back, we're going to talk about equilateral triangles.
Equilateral.
Equilateral.
If one angles are all the same, one side they're all the same. So let's just, all
Yes.
the same.
So, we said isosceles means that exactly 2 sides and therefore 2 angles are the same. In an equilateral triangle, all sides are the same. And that also means all angles are the same. Right? So in every equilateral triangle, all the angles will be the exact same. They will all be 60 degrees. Every single time, no matter what, in an equilateral triangle. Do you have to what? Yes, we still have to look at equilateral triangles. Okay, so on this side, we're going to start with a proof. Okay? This one asks us to prove that if a line is parallel to one side of an equilateral triangle, then it forms another equilateral triangle. Okay, so if we look at this diagram, okay, we're given that triangle ABC is an equilateral triangle. And then we're told, well, these 2 lines, BC and PQ, are parallel. So from that, we want to conclude that APQ is also equilateral. Okay? So, what we're going to do, okay? I mean, our givens in this case would be triangle ABC is equilateral and that PQ and BC are parallel. Okay. Okay, so if I know that ABC is equilateral, what do I know about all of its angles? They're all going to be the same, right? So I could say Angle A is congruent to angle B is congruent to angle C. Right? All three of those angles will be congruent. And that's just the definition of equilateral, right? Okay, we could write it out a little bit more and say, well, if we have an equilateral triangle, then it's equiangular. Okay, but we can just write definition of equilateral. So now, what else can I say? Looking at this diagram, what other angles do I know are the same?
P and Q.
So P and Q are congruent? How do I know that?
Because they're on parallel line.
Yes, but we need one more thing before we get there.
Why
Right?
does it say angle B is congruent to angle 1? Do they correspond?
Yeah, that's what we need. Right? We know for sure that these two are congruent because they're corresponding angles. Same thing over here. I can say angle C and angle 2 are congruent because they're corresponding.
But how do we not know if it's not parallel? Both sides of the equilateral triangle. All of them the same angles. And it's parallel line. Angles the same line.
It does, and that's what we're proving. But we don't. There's no actual property or postulate to say that yet. We have to go through the process of saying, well, we know for sure that these two would be congruent and these two would be congruent because they're corresponding. Then, in the next line, then we could say, well, that tells us then that these two angles would be congruent as well. Right? So, we can put that all in one line. We can say angle B is congruent to angle 1 and angle C is congruent to angle 2. They're corresponding. Right. Now we can state that a bunch of different angles are going to be congruent. Right. Now we can say that, well, angles 1, I can replace angle 1 up here with angle B. I can replace angle 2 up here for angle C. So I can say angle A is congruent to angle 1, is congruent to angle C, or I'm sorry, is congruent to angle 2. Okay, I just replaced angle 1 here and angle 2 here, okay, because I know that they're congruent. I think that one looks a little bit more like substitution, but we could also say that it's transitive. So now, once I've proven that these three angles are congruent to each other, now I can say the triangle is equilateral. Okay? So now we can say triangle APQ is equilateral. And again, we could write out that if a triangle is equiangular, then it's equilateral, right? But we can just write definition of equilateral here as well. You okay with that one? I am. Right. Teacher. Are you okay? Think so? There is. There's a lot going on here. Right? I mean, the big idea is that if we know a triangle is equilateral, it's also equiangular. And vice versa. If we know it's equiangular, then it's equilateral. So the next part I think is a little bit easier. So that's a good question. So on all of these, we're saying these are equilateral triangles. So we know all three sides and all three angles are equal to each other, right? So if we're given angles, we can say, well, if this one's 6x, this one's 6x, and this one's 6x, then all three of them would add to. Yeah, so that's another way. We could say they all three would add to 180, or we could just say, well, that one has to be 60. Yeah, either of those methods will work. If we're given sides, I don't need to know a third side, right? I just know that those two sides are the same, right? Because if all three sides are the same, any pair of two sides would be the same as well, right? So if we're given angles, we can say each individual angle is 60, or all three angles add to 180. And if we're given sides, okay, well, we automatically know they're all going to be equal. So we can just set those two equal to each other. Les? Okay, so let's take a couple of minutes here and try some of these. It's already toast. It's toasted. I don't like crispy toast. I like it lightly toasted.
Squishy toast.
I mean, I guess it's still like slightly crispy, but not like super crispy.
Golden brown.
Yeah.
I like when it's golden brown. It's still like a little bit just like long inside too. Center. It's got shape in it.
I said this marker is about toast because it's not rated very well. Like, started rocking with that.
the emotional breakdown.
Get your tear ducts ready.
Mhm.
No, it's not all.
And then we might be copyright. Hey, that's not how it works. You just call it funny. Say, just like whatever. Say, sleep. You beat me.
What's your Fach? Do you still do angle, side, and that stuff in this?
I will actually, for number 7 here, because what we're gonna have to do is prove that these two smaller triangles are congruent, and then we'll be able to claim those two angles are congruent.
Question.
Alright, here are the answers for 1 through 6. How do we do?
Not failure.
Actually good. Any that we want to look at in further detail? Oh yeah. Oh, 7. Of 1 through 6. We'll do number 7 here in a second. We good on the algebra part? Okay. Then let's take a look at the so let's try to examine what's going on here. So they tell us that ABC, which is the whole thing, this big triangle, is equilateral. And then they also tell us that angles 1 and 2 are congruent. And from that, we want to prove that these two angles right here are congruent. Okay? Does anybody see a plan of attack?
D equals D. I mean, EB.
Okay, so that what's that's true, but what's our goal here? Like, what are we going to try to prove congruent, and then what? Amber?
You prove that all of the angles are congruent before you can prove that
All? What do you mean all of the angles? Like,
you need angle A.
Well, we know
well,
they
we
are.
know that because it's equilateral.
Oh, I got
We need to alternate angles to show that those two angles are congruent.
it. To show that angle, ABs and B and C are the same. No, right there, FA. No. This one. This
Well, yeah, that's the goal. That's what we want to prove.
Oh, I thought we had to do that first.
No, that'll be our final step. So what we actually need to do here is to prove that these two smaller triangles are congruent. Then I can claim that these two angles are congruent by CPCTC. Okay? So let's kind of go through that together here. Okay, statements, reasons. So I know for sure that angles 1 and 2 are congruent. And then I know that ABC is equilateral. Okay, so if I know that ABC is equilateral, wait, say that again?
For like 3, A, C is congruent to C, B.
Yeah, so I can say that all 3 of those sides are congruent. Actually, the only ones we really need, though, are these two, because those are the two full-length sides in the other triangles. So I'm just going to say that those two are congruent, AB and CB, but it would be true that AC is also congruent to those. Okay, so this is just definition of equilateral. Okay, and then we also already said that since they share a side, that side is congruent to itself. So I can say that BD is congruent to BD. Yeah, so our best plan of attack here is to show that these two smaller triangles are congruent, and then use CPCTC to say that these two angles are congruent. Okay, so this is the reflexive property. Okay. Now, I do have enough information to say that these two triangles are congruent. Right? I've got side, angle, side in both of them. No. It's not angle, side, angle. It's side, angle, side. Okay, so I can say triangle ADB is congruent to triangle CDB by side, angle, side. Okay, there's actually another way that we could have done that. We could have also said angles A and C are congruent instead of saying sides AB and CB are congruent. Okay, and then we could have gotten that those two smaller triangles are congruent by angle, side, angle, or angle, angle, side. Right? So now, once I've shown that these two smaller triangles are congruent, now I can claim that these two angles are congruent by CPCTC. So angle ADB is congruent to angle CDB. Okay. So I know that these proofs are maybe a little new, maybe a little tricky. Okay, but are there any questions?
So how do we know what CP, CTC